Hello, my name's Austin Lackritz, and today we're going to learn about D-Verb in Pro Tools. In D-Verb, there is 7 algorithm controls. We have hall, church, plate, room, room 2, ambient, and nonlinear. Of these controls, we also have a small, medium, and large option to each of them. These are our algorithm controls. These controls select one of 7 reverb algorithms. Selecting an algorithm changes the preset provided for it. Switching the size setting can change the characteristics of the algorithms that are not altered by adjusting the decay time and other user adjustable controls. I will now start off with hall. You can switch between each of these controls, small, medium, or large. Hall is a good general purpose concert hall with a natural character. Hall is a good general purpose concert hall with a natural character. Setting decay to its maximum value will produce an infinite reverberation. The next one is church. Church is a dense, diffuse space simulating a church or cathedral with a long decay time, high diffusion, and some pre-delay. The next one is plate. Plate simulates the acoustic character of a metal plate-based reverb. This type of reverb typically has high initial diffusion and a relatively bright sound, making it particularly good for certain percussive signals and vocal processing. Plate reverb has the general effect of thickening the initial sound itself. Next we have room. Room is a medium-sized, natural, rich-sounding room that can be effectively varied in size between very small and large. Next we have room 2, a smaller, brighter reverberant characteristic than room 1. Next we have ambient. Ambient is a transparent response that is useful for adding a sense of space without adding a lot of depth or density. Lastly, we have nonlinear. Nonlinear produces a reverberation with a natural buildup and an abrupt cutoff, similar to a gate. This unnatural decay characteristic is particularly useful on percussion, since it can add an aggressive character to the sounds with strong attacks. Another part of D-Verb is the size controls. The size controls consist of the diffusion control, decay control, pre-delay control, high frequency cut, and low pass filter. Diffusion control. Diffusion sets the degree to which the initial echo density increases over time. High settings result in high initial buildup of echo density. Low settings cause a low initial buildup. This control interacts with the size and decay controls to affect the overall reverb density. High settings of diffusion can be used to enhance percussion. Use low or moderate settings for clearer and more natural sounding vocals and mixes. Decay control. Decay controls the rate at which the reverb decays after the original direct signal stops. The value of the decay setting is affected by the size and algorithm controls. This control can be set to infinity on most algorithms for an infinite reverb at times. Next we have pre-delay control. Pre-delay control determines the amount of time that elapses between an original audio event and the onset of the reverberation. Under natural conditions, the amount of pre-delay depends on the size and construction of the acoustic space, and the relative position of the sound source and the listener. Pre-delay attempts to duplicate this phenomenon and is used to create a sense of distance and volume within an acoustic space. Long pre-delay settings place the reverberant field behind rather than on top of the original audio signal. Next we have high frequency cut. High frequency cut controls the decay characteristic of the high frequency components of the reverb. It acts in conjunction with the low pass filter to control the overall high frequency contour of the reverb. When set relatively low, high frequencies decay more quickly than low frequencies, simulating the effect of air absorption in the hall. The maximum value of this control is off, which relatively means bypass. Lastly, we have the low pass filter. Low pass filter controls the overall high frequency content of the reverb by setting the frequency above which a 6 dB per octave filter attunes the processed signal. The maximum value of this control is also off, just like the high frequency cut. Thank you for tuning in to this week's tutorial. I will possibly be back with another one shortly. Have a good day.